Good evening, Sir Nepomuceno. Good evening, STEM 11A. I'm Randy Jr. Alonzo from STEM 11A. Our topic for today is finding standard normal distribution. Before we proceed for that, what is normal distribution? Normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing the data that near the mean are more frequent in occurrence than data far from the mean. In graphical form, the normal distribution appears as a bell curve. And let's proceed for the problem number 1. A company has a production line that is supposed to produce widgets with a mean weight of 10 ounces and a standard deviation of 1 ounce. However, due to various factors, the weights of the widgets produced follow a standard normal distribution. What is the probability that a widget will weigh less than 9 ounces? Solution number 1. To solve this problem, we need to convert the values to standard normal distribution using the formula, which is z is equals to value minus mean, or the deviation, divided by deviation, where x is the weight we are interested in, u is the mean weight of the widgets, which is 10 ounces, and the 0 is the standard deviation, 1 ounce. Substituting the values we get, z is equals to 9 minus 10 is divided by 1, which is the answer is -1. Next, we need to find the probability that a widget will weigh less than 9 ounces, which is equivalent to finding the area under the normal distribution curve to the left of z is equals to -1. We can use a standard normal distribution table or a calculator to find this probability, which is approximately 0.1587 or 15.87%, such that our mean will be 10, then the deviation is 1, then our value will be -9, so the possible answer is -1. Let's proceed to the standard normal distribution, or the bell curve. Our answer here is z is greater than 1 is equals to 0.3413 minus 0.5000 is equals to 0.1587 or 15.87%. We put our answer in the left side of 0 to negative side, which is 0.3413, and our conclusion is, therefore, the solution to the problem is that the probability of a widget weighing less than 9 ounces is approximately 15.87%. This means that there is a relatively low chance of this happening, given the standard normal distribution of widget weights. Let's proceed to the problem number 2. The average weight of bags of apples produced by a company is 1.2 kg, with a standard deviation of 0.2 kg. If the bags of apples are normally distributed, what percentage of bags will weigh between 1 kg and 1.5 kg? Solution number 2. First, we need to standardize the values using the formula, which is value minus mean is divided by standard deviation. For the lower limit, 1 kg is minus 1.5 kg is divided by 0.25 kg is equals to -0.5. For the upper limit, 1.5 kg minus 1.2 kg is divided by 0.25 kg is equals to 1.2. Now, we can find the percentage of bags that fall between these two values using a standard normal distribution table or calculator, such that -0.5 is less than 1.2 is equals to z is less than 1.2, then minus phi z is less than -0.5. Using a standard normal distribution table, we find that phi Z that Z is less than 1.2, that is equals to 0.3944, and P Z is less than negative 0.5, that is equals to 0.1915, which is such that our mean will be 1.2, our deviation will be 0.25, and our value or x will be between 1 and 1.5. Now, let's proceed for the normal distribution bell curve. So, negative 0.5 is less than the table of 1.2, that is equals to 0.1915 plus 0.3849, that is equals to 0.5764 or 57.64%. That will be our probability density. We put the negative 0.5 in the left side of 0, which is 0.1915. Then the positive side will be 1.2, 0.3849. Our conclusion is, therefore, approximately 57.64% of bags of apples produced by the company will weigh between 1 kg and 1.5 kg. Going to the problem number 3. An environmental organization is conducting research on the amount of plastic in the ocean. They collected data showing that the average amount of plastic found in the sample of ocean water is 3.5 micrograms per milliliter, with a standard deviation of 0.8 micrograms per milliliter. What is the probability that a random sample of ocean water will have an amount of plastic greater than 4.5 micrograms per milliliter? Solution number 3. We will use the normal distribution to find the area under the curve that represents the probability of finding a sample of ocean water with plastic greater than 4.5 micrograms per milliliter. First, we will standardize the value of 4.5 using the formula, which is C is equals to value minus mean is equals to divided to sigma, which is our deviation, where x represents the value we want to standardize. 4.5 mu is the mean, 3.5, and sigma is the standard deviation of 0.8. Z is equals to 4.5 minus 3.5 divided by 0.8, which is 1.25. Next, we will use the standard normal distribution table or calculator to find the area under the curve to the right of Z is equals to 1.25. The area under the curve represents the probability of finding a sample of ocean water with plastic greater than 4.5 micrograms per milliliter. Using a standard normal distribution table or calculator, we find that the area under the curve to the right of Z is equals to 1.25 is approximately 0.1056. This means that there is a 10.56% probability of finding a sample of ocean water with plastic greater than 4.5 micrograms per milliliter. The standard normal distribution bell curve. Our answer here is Z is greater than 1.25 is equals to 0.3944 minus 0.5000 is equals to 1050. Our probability density, we put our answer in the right side of 0.3944, which is our probability answer. Our conclusion is, therefore, the solution to the problem is that there is a 10.56% probability that a random sample of ocean water will have an amount of plastic greater than 4.5 micrograms per milliliter. And that's all. Thank you and happy Holy Week.